inorganic analysis experiment. So the purpose of this experiment is to observe the behavior. Welcome to the qualitative inorganic analysis experiment. So the purpose of this experiment is to observe the behavior of 4 different cations. So we're going to be looking at barium, magnesium, cadmium, and aluminum. And so these are Lewis acids. And so we're going to be testing these cations against 4 different solutions that contain ligand sources. So these ligand sources are common anions and ammonia that are be acting as Lewis bases. So the solutions are going to contain sulfate, phosphate, hydroxide, and ammonia. So we're going to be observing, first, does a precipitate form? Do these cations and anions come together to form a solid precipitate? And then second, if a precipitate forms, will a complex ion form with the addition of more ligand? And then lastly, when we have that precipitate or that complex ion, what happens when we acidify the solution? So we're going to be looking for the formation of precipitate as well as the formation of complex ion. So there will not be very many complex ions that we will see in this experiment, but there will be a few, so watch out for them. In this experiment, precipitates will form with 3 different sources of anions. So we will see precipitates with hydroxides, sulfates, and phosphates. Complex ions, those can form with hydroxide and ammonia. One of our sources of hydroxide will be sodium hydroxide, but we actually have 3 different sources of hydroxide. So NaOH produces hydroxide in solution, ammonia produces hydroxide in solution, and our source of phosphate also produces hydroxide in solution. So when we have sodium hydroxide, we can form a hydroxide precipitate or complex ion. Remember, in the activity this week, we saw that aluminum forms a complex ion when we have excess sodium hydroxide present. If we have ammonia in the presence of water, ammonia forms ammonium cations and hydroxide anions in solution. And with phosphate anions in the presence of water, we can also reform the weak acid, the conjugate acid of our base, and as a result, we also produce hydroxide. So in the video, there will be 4 test tubes containing the 4 cations. So each test tube contains a different cation. So say I have a test tube with one of our sources in it. First, I will add a drop to the test tube. So if a precipitate forms, we write down the chemical formula. If nothing happens, we put NR for no reaction and simply move on to the next test tube. So this is with the addition of 1 drop of ligand source. We see a precipitate, we write down the chemical formula, no reaction occurs, we move on to the next test tube. So say we added 1 drop and a precipitate did form. So here we have our test tube, and now we have a precipitate at the bottom of our test tube. So now we would add 1 milliliter of the same solution to our test tube. So I'm going to put several drops to indicate that we're adding more, that we're adding in excess of our ligand source. So if the precipitate dissolves, we need to determine the name of the complex ion. Next, we would add acid. So we have our test tube. So say our precipitate did not dissolve upon the addition of more ligand source. So we still have our precipitate at the bottom of the test tube. So now we're going to add acid to the test tube. So if we have a precipitate and it dissolves in acid, we would put an A. If we do not have a precipitate, so say we had a complex ion, and a precipitate forms with the addition of acid, we would put a P for the formation of a precipitate. So once the table is complete, we will use this information to construct a flowchart. So in a flowchart, we are starting with a solution that contains all 4 cations, and we now have to use our solubility observations to separate each ion from solution. So for example, we are starting with a solution that contains barium, magnesium, cadmium, and aluminum. So my first step, I need to use one of our ligand sources to form a precipitate so I can separate one of these cations from solution. So for example, in your first row in your table, you should hopefully observe that barium forms a complex ion with sulfate, but none of the other ions do. So we should know from table So we know from the table barium precipitates with sulfate. So we are going to use this precipitation to remove barium from our solution. So I'm going to make a note here that we're going to add our source of sulfate. And what we would expect to see, we would have a precipitate form. So PPT represents precipitate. And that precipitate is barium sulfate. Whereas we would have a solution remaining. And in that solution, we still have the 3 remaining cations. And so if we were in the laboratory, we would use a procedure called centrifuging. So basically a centrifuge is a large circular machine. You stick your test tubes in there, the machine spins the test tubes around really fast, and it uses gravity to separate the solid from the liquid, and then we can decant the liquid off the top of our precipitate. So in our procedure, we would centrifuge, wash our precipitate, and so these are the actual laboratory steps we would take. But what we are concerned with this flow chart is a big picture of what are we separating And what are we using to separate it? So we're using sodium sulfate to form a barium sulfate precipitate. Our other 3 ions are left in solution. So once the barium is removed, we do not need to include it in any further steps. Barium is gone. So all we are concerned with now is the magnesium, cadmium, and aluminum. So now I only have 3 ions. So how do I isolate one ion from the other 3? So we're going to use the information in our solubility table. I know aluminum forms a complex ion with hydroxide, while magnesium and cadmium precipitate, and I would collect my solution and precipitate separately. The other option I have is I know I can add ammonia, and when I add ammonia, I can form a complex ion with cadmium and precipitate magnesium and aluminum as hydroxide solids. But since we looked at the aluminum complex ion in our activity this week, I'm going to use that as my next step in this flowchart. So we are going to add sodium hydroxide to this solution. And so that's going to form a precipitate. And that precipitate is going to contain both the magnesium hydroxide and the cadmium hydroxide as a solid. Whereas our solution is going to contain the aluminum hydroxide complex ion. So we have this precipitate that we've separated from our solution by centrifuging once again. And so before we can move on to separating these 2 solids, we first need to make sure that the aluminum is present in this solution. So we've got to add something to the solution to precipitate the aluminum and confirm that we did indeed separate it. So we should hopefully have in our notes that when we acidify the solution and add a source of phosphate, we can form a solid aluminum product, aluminum phosphate. So we've confirmed that aluminum was there in our solution, and now we can go back and separate the magnesium and cation. So for example, in this flowchart, what I would do is I would need to acidify the solution, and next I will let you figure out what ligand source you need to add in order to separate these 2 once you've redissolved them in solution. So we add the nitric acid. We'll now have an aqueous solution containing magnesium and cadmium ions again, so they will no longer be the hydroxide solid precipitates. And you'll need to figure out the next step in this flowchart to separate these 2 ions from one another.